friends, we're back, and today we're going to talk about angles of elevation and depression as they apply to word problems. So how we're going to use the concepts that we talked about over here, identifying the angle of elevation and depression, with actual situations. And the word problems I have here are a little bit absurd. Most of the word problems that you're going to see have to do with ladders or shadows or staring up at an airplane or boats or any manner of things. But I decided that we're going to go battle a giant raccoon. I wrote this several years ago. I don't remember why it was battling a giant raccoon, but I think I was feeling kind of absurd that day. So this is what we have. All right, so we've got a couple of friends, Gisela, Owen, and Katie. They're battling a giant raccoon, as one does. Okay, so we've got, I should draw a third person, our three friends. Now, it's important to remember, step one should always be to draw out your situation. Now, you don't actually have to do a work of art drawing. You just need to draw enough that essentially you can see the triangle that is being created, so you know how to use your trigonometric functions to help you out there. Okay, so we've got our friends, and then we've got our giant raccoon. Generally my raccoon, because I can't draw animals, my raccoon is a rectangle that has ears and an eye and a tail. There you go. It's a raccoon. Okay, so we've got our three friends, we've got our giant raccoon, and now the numbers come in. We know they're standing 35 feet away. So from here to here is 35 feet. And they're looking up at the raccoon at a 42-degree angle. Now, I'm not going to draw in that angle yet because there's one more important piece. If their eyes are 5 feet above the ground, okay, you're going to see something like that a lot if it involves a person looking up at something, because we don't generally lay on the ground and look up at things. In some cases we do, most of the time we do not. Most of the time we're standing and our eyes are not at ground level. So we're going to recognize that this right here is 5 feet, and they're looking up to the raccoon at this angle. So now we're going to draw another horizontal that is parallel to the ground. So this, some of that wasn't great. I'm going to redraw this line. That's slightly better. So this angle right here, I'm going to switch colors. This angle right here is 42 degrees. Now, hopefully you recognize that that is an angle of elevation, because it is from the horizontal eye line going upward. Okay, so now what we're going to do is we're going to figure out what we need to know and use that to figure out what trig function we're going to use. So the final question is, how tall is the raccoon? So that means that this right here essentially is our x, and then we'll come back to this space down here in a minute, okay? So our x is right there. So we know that, I'm going to bring this up and remind myself that this is 35 feet, okay? So we've got our angle, we've got this right here, that's the opposite side of the angle, and then our 35 feet is the adjacent side, because this is a right angle, and so this up here is the hypotenuse. So we don't know that, but we know our opposite and adjacent, which means we're going to use tangent. So tangent of our angle, which is 42, is going to be equal to the opposite side, oops, that's wrong, not over the hypotenuse, the opposite side over the adjacent side. So I'm going to have tangent of 42 equals opposite is x, that's our unknown height, over our adjacent side is 35 feet. Okay, so to solve for x, we're going to multiply both sides by 35. Those cancel. So x is going to be 35 times tangent of 42. So if you plug that into a calculator, we're going to end up with x is about 31.5 feet if we round. But that's not actually the height of our raccoon, because remember that horizontal was assuming the 5 feet above the ground over here that our eyes were at. So to find the actual height of the raccoon, we have to add 5 feet to this. So the actual height of the raccoon is going to be 36.5 feet. Okay? All right, so we're gonna move on with our situation. So we're still battling our giant raccoon, and now we have 3 more friends, Michaela, Nate, and Sarah, and they're coming in to help out from their hot air balloon, from which they plan to drop glitter grenades. Because as everyone knows, giant raccoons are very susceptible to glitter grenades. So we're going to draw our hot air balloon. Okay, that's as good as we're gonna get. And then we'll have our giant raccoon down here. Okay, and so we know that they're looking down at the raccoon at a 76-degree angle. Okay, this is where we have to be careful. So we're gonna draw their eyesight, and when we're to say looking down, we're going to actually just assume that they're looking down to where its feet are, because we're going to be dealing with the ground, and that's going to give us our right triangle. Now, the reason we have to be careful is because for a lot of people, the assumption is that that 76 degrees is right here. But that is incorrect. That is not our 76 degrees. Okay, because if you recall, the default of our eye line is horizontal. It is not vertical. So we don't look straight down. We look forward. And so when we say they're looking down at a 76-degree angle, what that means is they're looking down from their typical line of sight. So that means that this right here is a 76-degree angle. And so this is our angle of depression looking downward. Okay, and so just to kind of finish off the right triangle, I'm going to drop this straight down. All right, so now we've got that right triangle that we know that we're going to use. Okay, so what other information are we given? Well, the war balloon is 250 feet in the air, which means that this right here is 250 feet, but also that this over here is 250, because those are going to be the same distance. Okay, so 250 feet high, and we want to know what is their direct distance. So whenever you see direct distance, that means not this horizontal distance up here. It means literally directly from where the hot air balloon is down to whatever it is that you're looking at. Okay, so there's our x. So let's think about what we're going to want to use. So we've got our angle, we already know. And x, this right here, our direct distance, that's our hypotenuse because it's across from our right angle. And then the other value that we know, the height of the hot air balloon, that's opposite of the angle. So since we have opposite and since we have hypotenuse, we know that we're going to use sine. So sine of our 76-degree angle, and our ratio for sine is opposite over hypotenuse. So then if I plug in values, our opposite side is 250 over our hypotenuse is x. So this is a little bit trickier of an equation to solve. So we need to get the x out of the denominator. So we're going to do that by multiplying both sides by x. So now we'll have x sine 76 equals equals 250. And then to solve for x, we'll divide by sine 76. So when you plug that in, 250 divided by the sine of 76, you're going to get somewhere around, or you should, 257.7 feet. So, based on this situation, Michaela, Nate, and Sarah still have a bit to go before they drop those glitter grenades.